Good morning, all of you.
Good morning, sir.
Good morning, sir.
Let's start with our next topic. Okay, from the last some lectures, we are discussing about the how we can represent the logic for AI agent, so that AI agent can understand it and act accordingly and take the decision, just like the human beings can take the decision according to their uh, logic or the knowledge. So previously we have discussed the one of the way of representation of knowledge, that was the proposition logic, and some of the things related to the proposition logic already we have covered with some examples. And also we have discussed how we can represent the certain propositions or the sentences or the facts from the real world with the help of the proposition logic. And also we have discussed there are the more are the limitations related with the proposition logic, okay, for the purpose of representing some kind of knowledge. Now we have seen already the some kind of limitation, okay. But let's see some in another. Okay, before we start with the first order logic, that is our next type of knowledge representation. Just we will just go through the some limitations of the proposition logic that will help us to understand the what exactly is the first order logic. Now in the proposition logic, we have seen how we can represent the different statements or the proposition using the proposition logic with the help of the different proposition symbols. But if you see in the proposition logic, we can only represent the knowledge or the facts which are either true or which are either false. Only that kind of statement which we are referring as a assertive sentences or the assertive statement, or we are also calling it as a declarative sentences. Only that kind of sentences or the facts we can represent using the proposition logic. Okay. And if you have other kind of statement which are different from these declarative sentences, the sentence which contain the another different kind of keywords, then that kind of sentences we cannot represent using the proposition logic. So that is the one of the drawback or the limitation of this proposition logic. Because if you see in the word, there are just not the facts are present, or there are not just the declarative sentences are present, there are the different kind of sentences and the different kind of facts are present. Next we will see that. So we need the kind of logic which can represent the everything from the world, understood, not just the fact as the declarative sentences, but we need the logic which can represent everything from the world. But the proposition logic is not having that much amount of power, and that's why we are saying it is having the limited expressive power. It can represent only the limited knowledge. Yes or no? It can represent only what? Limited knowledge. But we want the logic which can represent every kind of knowledge, understood. And for that purpose we are having the first order logic. Now for example, if you have the sentence, yesterday also I have given the example of some sentences. For example, some humans are intelligent. Now can we write the proposition logic for this? Is it possible to write the proposition logic for this sentence? Some humans are intelligent.
No, sir.
No. If even if you try to write the logic for that, only the logic you can have is like you will use some proposition symbol like a, and you write this statement in front of that. That is not the logic, understood. Here we not having any kind of when you represent like this, then we are not getting any kind of relationship here. It is a simple sentence, but it is this sentence is having some kind of relationship, but this relationship cannot be shown or cannot be represented using the proposition logic, because proposition logic is not having that much amount of expressive power. And in order to represent then such kind of sentences, we need to take the help of the first order logic. Another statement also I have written, Sachin likes a cricket. Now this statement cannot also be represented. This is nothing but the part of knowledge base. Understood? This is nothing but the one kind of fact within a word. But this cannot be represented in the proposition logic. And for that purpose, we need to take the help of the another powerful representation, and that is nothing but our first order logic. Now there is another major drawback of the what we are saying regarding the proposition logic. Okay. Now what that major drawback? That proposition logic is the context independent. It is what you might, if the you might also get the question to prove that why the proposition logic is considered as a context independent. Now let's we understand this with some example. Suppose first statement we are having here, Radha started feeling the feverish and Radha went to the doctor. Okay, Radha started feeling the feverish and Radha went to the doctor. Now what does it mean? Yes. What is the meaning of this sentence?
Radha has a fever and he went to the doctor.
She went to the, she has a temperature and that's why she went to the
Hmm.
doctor. Understood?
Hmm.
Now,
Yes,
Yes,
sir.
sir.
now if you assign the proposition symbol to represent this statement, for example, I denote the first sentence by the A and second sentence by the B. Correct?
Yes.
Then I can represent this sentence as a like this, A and B. Correct? The logic is
Yes, sir.
using the proposition logic is this. Correct? But if you have the second statement like Radha went to doctor and Radha started feeling the feverish. Now according to the our natural language understanding, okay, according to our natural language understanding, these two sentences, this one and this one, are having the same meaning or the different meaning. Yes, according to the natural language understanding, these two statements are having the different meaning.
Yes, sir.
Like here, for here, Radha is feeling something. Radha is not feeling well. That's why she went to the doctor. But here, Radha went to the doctor first, and then she started not feeling well. Is that is the meaning?
Yes, sir. Yes.
Correct. And if you represent this second, now how to represent the second statement using the proposition logic? It is like it is nothing but the reverse of the previous one. Yes or no?
Yes, sir. Yes, sir.
But
Yes, sir.
but according to the proposition logic, these two statements are having the same meaning. What is our, according to the rule of our proposition logic, these two statements are having the same meaning. Yes or no?
Yes, sir. Yes.
Like we know A and B should be equal to the B and A
Yes, sir.
according to the proposition logic. All of you agree?
Yes, sir.
Yes.
And that is the reason I am saying that the proposition logic is the context independent. Is it correct?
Yes.
Yes, कारण याचा context वेगवेगळा आहे. But what the proposition logic is saying, no, context is the same. And that is the reason here I have said the proposition logic is the context independent. So that is not the, this is not the proper way of its meaning of this two statement is different, but proposition logic is saying no, meaning is the same. So is it the correct way of the representation? Are we getting the correct, logic by utilizing the proposition logic if you have this kind of sentences?
No.
No, sir.
No. And
No,
that is
sir.
another limitation of the proposition logic. So in the above example, you can see the A and B and B and A should have the same meaning, but in natural language words, the sentences may have the different meaning. So that is
Different meaning.
one of the limitations related with the proposition logic. And To avoid such kind of limitations and many more limitations of the proposition logic, we have the another kind of logic, that is the first order logic. First order logic. Now this kind of logic is also called as the predicate logic also, for your kind knowledge, for your kind information. First order logic is also having the another name, that is the predicate logic. In the example question may get in the different way. Okay. Or it is also called as the first order predicate logic also, FOL or FOPL. Okay. So first order logic is the another way of knowledge representation, just like first one we have seen the proposition logic in artificial intelligence. And as it is the second category of formal logic, that's why it is considered as a extension to the proposition logic. And it is sufficiently expressive as compared with the our first logic, that is the proposition logic. And it is have the expressive power to represent the any kind of natural language statements. Okay. It is also being known as the predicate logic, that I'm already told you. First order logic, it is also called as the predicate logic or the first order predicate logic also. FOL is the powerful language that develop the information about the objects in more easy way and can also express the relationship between these objects, which is not possible using the proposition logic. But first order logic not just consider in the word only the facts or only the declarative sentences are kind of present, but first order logic thinks that in the word there are the different things are present, there are the objects are present. In what you mean by the object, etc., we'll see that. So FOL think that there are the different objects are present, within that object there are the different kind of relation is there. So in order to represent that, FOL is the more powerful. So first order logic, like the natural language, does not only assume that the word contains the fact like the proposition logic, but it also assumes that the word consists of the following important things are there. So according to the FOL, the word just not contain only the facts or the declarative or assertive kind of sentences or the proposition, but it consists of the various another kind of things in the word. Now, which are that various another kind of things are available in the world, which has to be considered, and that is also being considered by the first order logic while representation of knowledge. Now, which are that other kind of things, like there are the number of objects are present in the world. Objects can be anything: peoples, numbers, alphabets, colors, wars, theories, squares, speeds, bumpers, anything. Anything which is present in the world can become under the category of objects. Then there are the number of relations are available in the word, like it can be a unary relation such as a red, round, is adjacent, or any other relation like sister of, brother of, friend of, has color, father of, comes between, like this. So these things are present in the word. Like there are the other different kind of functions are present, properties, characteristic are there, like best friend, third inning of, end of, like this kind of different kind of categories of the things are present in the word, functions are present in the word. And that is the, now these kind of things are being not able to being represent, or the proposition logic is not having that much amount of expressive power to represent all these kind of things. Understood? And that is the reason we need to utilize the first order logic, and using the first order logic we can represent all these kind of things which are present in the world. Okay, that we'll see in the next. Now let's see the, now these things already we have discussed. The according to the first order logic, word consists of these different kind of things. You should keep in mind this. According to the FOL, word contain the different objects, relation, function, relations, etc., etc. Now let's see the some of the things related with the syntax of the first order logic. Just like in case of the proposition logic also we have discussed the syntax and the semantics. Now syntax of the FOL determines which collection of the symbol is a logical expression in the first order logic. Means what? Which kind of symbol we have to utilize. Okay, which kind of symbols we have to utilize in order to represent the knowledge. Okay, that is nothing but the syntax. Just like in case of the proposition logic, we have utilized the proposition symbols, etc., etc., logical connective, these different things are utilized. In case of the FOL also, we are also going to utilize the different kind of symbols and the logical connectives also. Okay. So the basic syntactic element of the first order logic are the symbols. Everything depends on the symbol. With the help of the symbol, we are going to write the different kind of logic that will come under the category of first order logic. Now here are the some basics elements related with the syntax, which is very important, because if you know these, then only we can write the different kind of FOL for the knowledge representation. Now what are the basic elements in case of the FOL? The basic elements, like there are the constants. Now what can be the constant? Constant can be the number, constant can be the name of any country, state, constant can be your name also. Variables, some you must be knowing constant is something which generally not get changed, correct? And also the another basic element, we have the variables, like which can be get changed, like x, y, a, b, etc. Something which can get changed, that come under the category of variables. This is important. Predicates. Now predicates is what? Predicate generally indicate the, what you can say, property of something, or the relation, characteristic. These things are come under the predicates. Like for example, I have written here the brother of, father of, sister of, greater than, equal to, less than, equal to, greater than, less than. These things comes under the category of predicates. Functions relation, like square root, cube root, left leg of, left right leg of, these kind of things under the functions relations. Then connectives. Now same kind of connectives that we have discussed in the proposition logic also, like negation, implication or the conditional, conjunction, disjunctions, biconditional or the dual implications. So these things comes under the connectives. Then equality element, this is the equality element. And most importantly, and which is something new for you, that are the quantifiers as another basic elements of the FOL, that is the quantifiers. Now this is the one quantifier, this you can see, this is the reverse or the inverse of the A, which is called as the universal quantifier. If you have the notebook, you can note down it. It is called as the universal quantifier. And second quantifier we are having here, that is called as the existential quantifier. Second quantifier as a existential quantifiers. Okay. So based on, by utilizing these different kind of symbols or the basic elements, we are going to write the first order logic for the different things being present in the world, or for the different knowledge which is being present in the world. Understood this point? Remember this, or if you have a notebook, you can note it down, because we are going to require this while writing the logic. Yes.
Yes, sir.
Okay, then let's move forward. Now just let's understand some more things about the the FOL. And here we have the first order logic statements are like what? So first order logic statement, FOL statement, generally consists of the its main part as a subject, and another part of the first order logic statement consists of the predicate. Now what do you mean by the subject? Just like in case of the natural language, subject is nothing but the main part of any kind of statement. Yes or no?
Yes, sir.
Then predicate, as already I told you, a predicate is defined like as it is a relation. Predicate as a part of the statement can be considered as any kind of relation, attribute, property, characteristic, which binds the two or more than two things or the atoms together in the statement, that is called as the, what we can say, the predicate. Let's see in the example, in case of some example, what exactly these things are mean. For example, I have written the statement x is an integer. What? X is an integer. Now, what is the subject of this statement? What is the subject in this statement?
X.
X is the subject. Understood. And what is the predicate?
Integer.
Is an
Is a
integer.
Integer is a predicate because it indicates some kind of what we can say the attribute. Okay, it is a kind of attribute character. It is simply the attribute of subject X. Understood. So here we can
Yes, sir.
see the given statement consists of the two parts. Like the first part, X is a subject of the X is a subject of the statement, and second part is the integer, which is nothing but considered as a predicate. Okay. So using these two, using these two things, we are going to write the first order logic for the different kind of things which are present in the word. Now, in the example, you might be asked to explain the concept of the first order logic or the proposition logic, and but most of the time questions are being asked like you have given some natural language sentences and you have been asked to write the proposition logic for that, to write the first order logic for that, etc., etc. 6 marks, 8 marks question are always being asked. You can check the different previous question paper also. Number of times you have been asked to write the logic for these different things. Okay, that examples we are discussing. Now let's start with the example so that the things will get more clear. Now here we have the first example. Stephen was intelligent. I hope all of you can able to see it clearly.
Yes, sir.
I have written the statement Stephen was intelligent. Now tell me what is the subject in this statement?
Stephen.
Stephen is the
Stephen.
subject. You can easily see, and I have written there also. Now what
Yes,
is
sir.
the predicate?
Intelligent.
Intelligent.
Intelligent. As you can see, this is nothing but the predicate as an attribute, property, or the characteristic, which we are calling it as a predicate. Now, how then we write the FOL for these? Now, in order to write the FOL for these, we should write first the predicate. Keep in mind, when you are write the FOL, first what we will write? First we will write the predicate. Now, related with this statement, what is our predicate? Intelligent.
intelligent.
So first we write the predicate, that is intelligent, then followed by the predicate within a parenthesis. Within a parenthesis, we have to write the subject. Now, what is the subject?
Stephen.
Stephen. And that is the reason FOL, first order logic for this statement is this. Got the point?
Yes, sir.
Now, do you tell me, using the proposition logic, is this kind of representation is possible? Now, this is
No.
just a simple example I have given. We are going to see the more examples, then you will understand. For example, see the second example. Amir and the Shah Rukh are the rivals. Amir and the Shah Rukh are the rivals. Now, how we can write the logic for this statement? Now, which is the first thing we should you should when you are writing the logic? Now, these things are already asked in the exam. Now, when you are writing the logic for this, you should first understand what is the predicate within that statement. Now, what is the predicate within this statement?
Rivals.
Rivals is the predicate.
Yes, sir.
And what are the only one subject is there or more than one subjects are there?
More than one Amir and Shahrukh.
Amir and the Shah Rukh are the subject. So we write the predicate first, correct? And
Yes, sir.
then what we have to write? Then you have to write
Subject.
the subjects like Amir, comma Shah Rukh.
Shahrukh.
Now, how you will read this logic? How you will read this logic? Amir and Shah Rukh are the rivals. In this way, you can read this. Got the point?
Yes.
Let's see the more complex sentence. Richard father is married to the John's mother. This is being asked number of times in the example. Richard's father is married to the John's mother. Now it is a complex sentence.
Yes, sir.
Now how we can write the predicate logic for this. Now, first I told you, you should identify what are the predicates are there.
Married.
Married is the main predicate.
Yes.
What are the another predicates also?
No, Richard father is married to John's mother.
Father and mother.
Exactly, father and mother are also other predicates. But as compared with the father and mother, which is the main predicate? Married.
Yes.
So we will what we do? We will dissect this statement, or we will fragment this statement first, and then we'll write the main logic. Just like we have fragmented now. As we have fragmented, this is our main predicate, married. Got the point?
Yes, sir.
This is our main predicate. Everything which is there will come under this parenthesis. Now, what are the other two predicates? Father and mother. So
Yes, sir.
another predicate is the father. Okay. Now, father and related with the father, what subject we are having? In the statement, we have the Richard father.
Richard.
So father is the predicate, then its subject will be Richard.
Yes, sir.
Similarly, as a mother is the predicate, its subject will be the John. Got the point?
Yes, sir.
And then finally we will write the FOL for this, first order logic for this, like this. As you can see below, as first you have to write the main predicate, that is the married.
Married.
Then followed by that you have to write the two other sub predicates and their subjects. Other predicate we have the father, followed by the subject Richard, comma, mother, followed by the another its subject John. So this is nothing but the FOL, first order logic for this given statement. Understood this?
Yes, sir.
Now how we'll read this? We'll read this like Richard father is married to John's mother. So it is being read like this. So this is the basic example related with the predicate logic or the first order logic. Understood these three examples?
Yes, sir.
Let's see some more. Now before that we understand some type of sentences in case of the first order logic. So first order logic generally consists of the two kinds of sentences. In that we have the first, the atomic sentences. Now what are the atomic sentences? Here I have written, an atomic sentence are formed from the predicate symbols followed by the parenthesized list of items. Already we have utilized this in the previous example. Atomic sentence is formed from what? Predicate symbol. Like for example, this is the example. Take this example. Raj and John are brothers. Okay? Raj and John are brothers. Now what is the predicate of this? Now this is the atomic sentence.
Brother.
Brother is the predicate.
Yes, sir.
And subjects are
Raj and John.
Raj and John, which is you have written within a parenthesis. Now these Raj
Yes,
and
sir.
John are also considered as the terms in technical language. Raj and John are considered as what? Terms. Got the point?
Terms.
And that is the reason here you can see an atomic sentence is formed from the predicate symbol. Atomic sentence is formed from the predicate symbol brother, followed by parenthesized list of items. So within a parenthesis, we have list of terms, Raj and John. Okay, keep this in mind. So it's a formula also I have written. Atomic sentence is equal to predicate followed by the bracket number of terms. Getting?
Subject is like terms.
Yeah, subject you can consider as a terms here. Atomic sentence, then predicate. Yes, definitely the terms are considered as a like subjects. Now, what are then
Subjects.
terms? Also, I have written here. Terms can be considered as a function like constant, variables. That everything comes under the category of terms.
Terms.
Okay. Now let's see the another kind of sentence in case of the FOL, that is the complex sentence. Now, complex sentences are made from the atomic sentences using the connectives. Okay, if you utilize the atomic sentences with the connectives, atomic sentence with the connectives generally considered as a complex sentences. Like here I have written negation of S, negation of S1 and S2, negation of S1 or S2, negation, sorry, not negation here, S1 and S2, S1 or S2, S1 implied S2, S1 double implication S2, like this. So if in the atomic sentences, if you write the logical connectives, that becomes your complex sentence. Like here directly I have written the logic. Here the logic is given for some sentences. Sentences can be what? एक्झाम मध्ये असं पण विचारलं जाऊ शकतं की लॉजिक दिलं जातं आणि त्याच्यावरून तुम्हाला सेंटेन्स फॉर्म केलेलं, यू विल बी आस्क्ड टू राईट द सेंटेन्स फ्रॉम दॅट. गेटिंग?
Yes, sir.
So what can be the sentence for these? Can you tell?
Sibling of John and Raj. This implies simplest to the Raj to John.
Sentence. Tell me the
Sir,
sentence.
it's
What sentence will from this logic?
John is sibling of Raj.
Ah, yes.
John is a sibling of Raj, and Raj is sibling of John.
Sibling means what?
नेबर जवळचा राहणारा बाजूचा
Oh,
Hmm?
शेजारचा ना सर.
Real brother sister.
Hmm. Siblings means what?
Belongs to same parents.
Same parents. Correct na? Like here now. So what will be the statement will from this? If John and Raj are siblings, then Raj and Johns are also siblings.
Yes sir.
Correct or not?
Yes sir.
Implies if John and Raj are the siblings, then Raj and John also can be the siblings.
Yes sir.
Understood? So the question might be asked in the what you can say in another way also. You might be in the exam logic might be given, and from that logic you have to write the sentences. Let's move forward. Now main thing we should discuss in the FOL, that are nothing but the quantifiers, and number of time the question being asked on the quantifiers only. Now what are the quantifiers? Just like the other symbols, the quantifiers are also the symbol, but it is having the more expressive power. Okay, these are also like the what we can say the symbols like other symbols, but it is having the more expressive power. So here I have written the quantifiers are the symbol that permit to determine or identify range and scope of the variable in the logical expression. Okay, with the when you understand the example, you will understand what I have written here. Now, two types of quantifiers are there mainly, as I previously also told you. Universal quantifier. Now, what is its symbol? What is the symbol of universal quantifier and existential quantifier?
Universe A.
Inverse A is the symbol of the
Yes.
universal quantifier,
Universe
and
E.
existential
E.
quantifier, like this we have the symbol related with the. Okay, so two types of quantifiers are there. First, as I am saying, the universal quantifier, which is having the symbol like this, and second we have the existential quantifier, which is having the in reverse of the E, like this kind of symbol. Now, for what kind of things can be represented using the universal quantifier? That is the main thing. What kind of things can be represented with the help of the universal quantifier? Now, if in the word the sentences are having the mentions like for all, everyone, everything, if these things, if these kind of words are present in your sentences, which are being present in the real world, then for the purpose of representation of that kind of things, we can utilize the universal quantifier. Okay, keep this in mind. Okay, if you know this, then only you can write the logic using the universal quantifier and the existential quantifier. Then what kind of things can be represented using the existential quantifier? Like some, for some, at least one, like this kind of things can be represented using the existential quantifier. Now there are the special kind of connectives are being utilized while you are writing the logic using the universal quantifier and the existential quantifier. So in the universal quantifier, we use this implication connective. This is important. Keep in mind this. In case of the universal quantifier, what we have to use? Implication connective. In case of the existential quantifier, we always use the and conjunction as this symbol. For the and connective, we have to utilize in the existential quantifier. So these are the mandatory things related with these two quantifiers. You should keep in mind this. What first thing is what is the symbol of the universal quantifier? Second, what is the symbol of existential? Now what connectives are being utilized in the universal quantifier and what connectives are being utilized in the existential quantifier. Okay. Now let's see the example of these. Now you can see. Now this is the general format of writing the logic using the universal quantifiers. Okay, general format I am telling you. What is the general format? The universal quantifier symbol followed by variable and the sentences. Okay, keep in mind this. Universal quantifier symbol followed by some variable and the sentences. Let's check out the example. This is the example. Every cat drinks milk. What? Every cat drinks milk. Now, can anybody tell me if using the proposition logic, if you are to write the logic of this statement, like every cat drinks milk, then it is possible to write, but you have to write that proposition logic statement for every cat. Every cat in the sense, we don't know how many cats are present in the universe. Do we know this? How many cats are present in the world?
No.
No, sir.
Even if you consider 1 lakh cats are present, correct? So if you
Yes, sir.
want to write the proposition logic, you have to use the 1 lakh proposition symbols. What? You have to write the 1 lakh proposition symbols and then you have to write the logic for that. That is the main drawback in case of the proposition logic. But if you try to write the logic in the first order logic, let's see how it can happen. What is the statement? Every cat drinks milk. Suppose I consider this is the universe of discourse, म्हणजे whole world. आणि आता आपण इथं काय कन्सिडर करू की in the whole world there are only 3 cats are remain. How many? 3
ठीक
cats
आहे.
are remain. Their names are X1, X2, X3. Their names are what? X1, X2 and X3. X1 drinks the milk and X2 drinks the milk and X3 also drinks the milk. Correct?
Yes, sir.
Then how we can write the logic for this? Now logic for this is very simple. You can see here. As I mentioned here, universal quantifier followed by the variable X. Now what is the X?
Cat.
X are that whatever number of cats are there.
Yes, sir.
Correct or not?
Yes.
So universal quantifier followed by the variable colon followed by cat in bracket X, then which implies drink in bracket x comma milk. आता मी सांगितलं की first thing you should identify from this statement is what are the predicate and what are the subjects. Now what are the predicate within this what you can say statement?
Drink.
Drink is the predicate.
Predicate.
Understood?
Yes, sir.
So drink is our predicate, and now in order to represent the subject we are utilizing the symbol x. I hope you are getting.
Yes, sir.
Understood? And that is the reason here I have written universal quantifier x colon cat x implies drink, as drink is our main predicate. Drink in bracket x comma milk. Now how to read this logic? For all x, meaning of this statement, meaning of this part, for all x. What is the meaning of this next part? For all x, if x is a cat. Getting?
Yes, sir.
For all x, that's the meaning काय? For all x, if x is a cat, then, now what is the meaning of this third part? Third part of logic. Then x drinks milk. Getting? Yes?
Yes, sir.
For all x, if x is a cat, imply कशासाठी यूज केले आपण? Imply indicates then x drinks milk. Now what is the x?
X is a cat.
X is a cat. Understood? And this is nothing but
Yes,
the
sir.
logic for this particular sentence. That every cat drinks milk. Is this logic is correct? Yes or no?
Yes, sir.
Yes.
Yes, sir.
Now you should understand how to read the logic also. You are getting, and that's why I have written here how to read this. Meaning of this, for all x, if x is a cat, कारण आपण x कुणासाठी यूज केलाय? cat साठी.
Every
For
cat.
all
Yes,
x, if x is a cat, then x drink milk.
milk.
Got the point?
Yes, sir.
Now
Yes, sir.
more example you will solve, the idea will get more clear. So let's see the another example also. Here example is what? Everyone at integral is smart. Everyone at integral is smart. So what logic we have written? See here. Universal quantifier x. What does it mean? For every x. If x is an integral, for every x, if x is an integral, then x is a smart. Meaning of this, then x is a smart. Now you can write this in some another way also, like let me show you. Just like I have written here, x comma integral, you can also write it like the integral and in front of that x also. It also correct. You are getting what I'm saying?
Yes, sir.
Just here लिहिलंय तसं you can write it like this, integral, and in front of integral you can also write the x. It is also correct. So what does it mean? For every x, if x is an integral, then x is a smart. Understood this? Yes. Everyone at
Yes,
integral.
sir.
Everyone at integral. So for this everyone, we have written this logic. Everyone at integral. Okay. Now at integral is everyone. So that's why we have write to this like x comma integral or integral in bracket x. What everyone at integral is what? Everyone at integral is what? Everyone at integral is smart. And that is the reason here we term smart is the our predicate, smart, and in bracket x. Got the point?
Yes, sir.
Let's see one more example, another example. This is a very common, which is being asked in the exam also. All kings are persons. काय? All kings are persons. All साठी काय लिहिणार आपण?
Universal
Universal quantifier and variable.
and X.
X is a variable. Xच यूज केला पाहिजे असं काय नाही, तुम्ही कुठला पण व्हेरिएबल यूज करू शकता. Correct?
Yes. Yes, sir.
All kings. So here for all kings, as king we are going to represent using the X. So for all X, for here all kings are persons. For all X, if X is a king, that is written like this, king in bracket X. Got the point?
Yes, sir.
For all X, if X is a king, then X is a person also. This is written like this. Then X is a person also. Then
Person.
X is a person. Got the point?
Yes, sir.
Let's see another example also. Now let's see the things related with the existential quantifiers. Now same example we write in the another way here. Some cats are duffer. What? Some cats are duffer. Now we don't know how many cats are there. So we'll assume that suppose x1, x2, x2, x3 are the, some cats are present. X1 is duffer, x2 is duffer, x3 is duffer. Understood. Now in case of the existential quantifier, which symbol we utilize? This symbol. Okay. And which
Yes, sir.
connective we utilize?
And
And. So what is the statement given? Some cats are duffer. For some cats, for आता cats आपण कशाने represent करणार? Which variable? X.
X.
So meaning of this what? For some X. If X is a cat, correct? For some X, if X is a cat, and he is the she is the duffer. So for some X, if X is a cat, then X is a duffer. But here we don't have to use the implication symbol connective. Here we have to utilize compulsory what? And symbol.
And
That is the existential quantifier. Understood? The same example we have seen regarding the existential quantifier in the different approach. Instead of their all, here some is mentioned. And when some, at least this kind of things are there, then we have to utilize the existential quantifier and this kind of symbols. For some X, if X is a cat, then X is a duffer. Let's see one more example related to this. Some prime number is a even number, or some prime numbers are the even number. How we should write the FOL for this using the existential quantifier? Now some word is there. For some we write the symbol like this, existential quantifier, followed by the variable X.
X.
Now some prime number is even number. Now next is what? Prime. Now here for some X. Now X is X is for what we are utilizing? For number.
Some number. Yes, sir.
So for some X, if X is a prime, it is being written like this. If X is a prime, then X is a even also. This is being written like, then X is a even number also. Understood? So this is the FOL using the existential quantifier. Let's see the another example. Some students like bunk. Some student like bunk. Then I will write the FOL for this using the. ना आता इथं आपल्याला universal quantifier use करता येईल का? Can you use the universal quantifier for this?
No.
No, because some word is there. Understood?
Yes.
And if some word is there, we have to use the existential quantifier followed by the variable X. Understood? For some X indicating here what? Student. For some x, if x is a student, if x is a student, for some x, if x is a student, and then that x student like the bunks, that is being written like this, like x comma bunk. What is its meaning? X like the bunk. Got the point?
Yes, sir.
So this is another example related with the existential quantifiers. Okay. So only the properties of the quantifiers are remain, that we'll see in the next lecture. But here I am giving you the some example. You can note it down. Here you have to write the FOL for these examples. Okay, you have to write the first order logic for these examples. These are the examples which are being asked in the exams. Okay.
Okay, sir.
Yes, sir.
Okay, so that's it for the today's lecture. Thank you
Thank
all
you,
of
sir.
you.
Thank you, sir.